Good afternoon, class. Welcome to your first physics lessons on light. Alright, so for the trigger activity here, what we will look at is this photo that I've taken, alright, on one of my overseas trips. Now, can anybody explain to me why we are able to see the mountain in the lake? Anyone would like to give that a try? Kenneth?
Maybe the light shine on the mountain so you can see reflect on the mountain.
Okay, very good. So you are able to see the mountain in the lake, alright, and you think that this is due to a natural phenomenon called?
Reflection.
Very good. Okay, so as you can see, for many of the things we see in nature, okay, we are able to see these objects because of this phenomenon called reflection. Later we'll discuss in greater detail. Alright, so I know in the lab, and I can just have a show of hands. Any of us have actually used a mirror before? A mirror. Doesn't have to be a plain mirror. Everybody, right? Everybody probably used a mirror before. Okay, very good. So when you look into the mirror, you actually see yourself. Okay, so that is what we call a reflection. Alright, using a simple term. But is it only true when we use a mirror then we get to see reflection? Might or might not be. What do you all think? Probably not, right? Okay, because for a lot of the things that we see in life, it is because of the light bouncing off and we are able to, see these items. Okay, so if everybody just refer to your worksheet, okay, along with me that I've passed to you. Okay, so we will discuss some of these very basic or introductory things before we go into some of the experiments we'll see later. Okay, so can anybody give it a try? Okay, just now, if you all still remember Mr. Gan's lesson on energy, alright? What is light? Anybody want to just give this a shot? What is light? Timothy, you want to give it a try? What do you think is light? Okay. Besides not being heavy, okay, what else is? What do you think? How do you interpret light?
Light give light energy.
Okay, very good. So Timothy just said that light is a form of energy. Okay, so please follow the lesson. Alright, you have your worksheet, you see the underlined parts, please fill in along the way together. Okay, so how does light travel? It gives you some time to think about this. How do you all think light travels? Okay, does it, go in a jagged way, or is it in a straight line whatsoever? Okay, Xiaofei want to give it a try? How does light travel? In a straight line, okay, but how are we certain, or how can we be sure that light travels in a straight line? Alright, so Xiaofei said that light travels in a straight line, and at this point in time, okay, we will watch a little YouTube clip to show us that light travels in a straight line. Okay, but before I actually play the video, alright, just a few things to take note of. Alright, later when you watch the video, take note of how the experimenter actually changes the position, of some of the cardboard boards. And take note of how this actually helps us see or learn that light travels in a straight line. Okay, so without further ado, let's have the video.
OP34 to show that light travels in straight lines. We will use this apparatus, three men with rectangles with holes.
Okay, so as you can see, what's happening here is that they are using three metal plates, alright, and there is a hole, right? There's a hole in the middle of the metal plates. Okay, so for a start, the metal plates are actually aligned. Okay, and what we're going to do here is to try to shine a laser beam through. Can you all see the laser beam at the end of this at the end of the board here? Let me just rewind a little bit. Down here, can see, right? Okay, so if you can see that green color light at the end, then what can we say? That the light actually managed to pass through, right? Okay, very good. So let's watch what happens when one of the boards are being misaligned. Okay.
We check that they're in a straight line by stretching the wire to make sure it's straight.
Okay, so let's have a look. Now what happens? Okay, that when one of the boards is being misaligned. So when one of the boards are being misaligned, the light is actually unable to pass through. Okay, why do you all think this is so? Anybody want to give it a try, Chandra? Why do you think this is so?
Because it's not in the straight line. All the holes are not in the straight line.
Oh, okay, very good. Okay, so Chandra said that now the boards are not in a straight line, therefore the green light is unable to pass through. Alright, so we do not see the green light at the end. Okay, very good. So what can we do? Okay, what can we do to actually make it such that we can see the light again? So this is one of the things that we can do. Alright, we can put a string through the 3 holes and pull it taut. Alright, pull it taut so that now the 3 boards are aligned again. Okay, so by doing so and then shining the light through it again, we're able to see that the light passes through. Okay, so this simple experiment is just to basically demonstrate that light travels in a straight line. Okay, so as you can recall from the previous lesson, there will be this small portion of the lesson whereby I will slow down a little bit and then I'll give you some time to think and then I'll skip a portion of it. Alright? So now discuss in your pairs, okay, how are you able to see objects and how can we classify the types of objects that we see in our everyday lives. Okay, so everyone just take a few minutes to do this. Okay, Alan, please discuss. If you do not have a partner, you can always join Timothy and Kenneth over there. Okay. Okay, so I hope you have spent quality time discussing with your partner. Okay, so let's just get some answers from the floor. Okay, Kenneth, would you like to share with us, what are some of the types of objects that you can see?
Real, virtual, and ghost object.
Ghost object, okay, what do you mean by ghost object?
Huh?
What do you mean by ghost
sometimes
object?
you can see, sometimes you cannot see.
Oh, okay, very good. Okay, so the way we can classify, one possible way to classify the objects is to basically think of whether they are able to reflect or give out light on its own, and or rather whether it has to reflect light from a source. Okay, so this part will be skipped, it's in your worksheet. Okay, so this part also. Okay, so for the most important part of today's lesson, what we are going to do here is to introduce or to learn some new terms, okay, in this chapter of reflection of light. Okay, so what we're going to do now, let's take a look at this simple diagram we have here. Okay, so just now, previously when we looked at the experiment, what happens here, okay, is that we have a plane mirror, as you can see at the bottom of the diagram. There will be an incident light coming in, okay, and it will hit this point over here, which we call it the point of incidence. Alright? Now, you can see this dotted line over here, right? So anybody want to make a guess what's this dotted line called? It's called the normal, very good. Okay, so when the incident ray hits the hits the point of incidence rather, the ray that bounces off will be called the reflected ray. Okay, so I know that this particular diagram and terms are very new to some of us here. So in order to help us, remember this better, I think I prepared a simple video here to help us relate to some of the activities that we do in our everyday life. So before I show the video, just a quick show of hands. Anybody of you play pool? Come on, Timothy, I know you do, right? You play pool?
See in the pool.
No, not that kind of pool, Timothy.
Okay.
Okay, so basically, before I show the video, alright? Now, these are 2 questions that you want to think about. Firstly, with relation to the pool, the game of pool, alright? Where is the point of incidence? And secondly, what do you think is the relationship between the angle of incidence and the angle of reflection? Okay. So let's have a quick look at the video.
Amsterdam.
Okay.
teach you how to aim a bank shot. The way a bank shot works is hit the cue ball to the object ball.
Okay, so now the pool player here is a master pool player is trying to show us how to aim a bank shot. Okay, so a bank shot is a shot whereby the ball, the cue ball, will hit the colored ball and then it will bounce off the table and go into the hole. Alright, so the idea here is to get the colored ball to bounce off the table. Okay, so you do not need to know exactly how this is done, but you need to appreciate, alright, how he actually makes some sort of measurement, as you can see here. Alright, okay. So what he has done so far is to measure an angle, alright, and try to make sure that the angle of incidence, which I'll show you on the diagram later, is equal to the angle of reflection, after which he will execute the shot. Okay? So before we show the outcome, before we show the outcome, now how many of you think that he will succeed in making this shot? How many? Oh, most of you think so. Maybe you watched the video before, maybe sometime last week, someone showed you. Okay, so why do you all think that he will be able to make the shot?
So you say he's a master pool player.
Very good, because he's a master. How do you know?
Because you said so.
Oh, because I said so. Okay, very good. Okay, anybody else? Alan, want to make a guess? Why do you think he's able to make the shot?
Last week I watched the same video.
Oh, you watched the video before. Okay, very good. All right. So yeah, okay. So let's have a look. Let's see whether he's able to make the shot.
I lift up my cue stick and draw a line through that.
Let's go a bit.
Look it up. And wherever that is pointing to on the rail, that's where the ball is.
Okay, so let's see. All right. So let's see whether he's able to make the shot. Oh, okay. Can we give him a round of applause, please? Okay, very good, right? Okay. So next time you go out with your friends, you can show them, all right, that you learn in physics how to make a bank shot. Okay, so now to relate to the video that we just watched, okay, you can see on this diagram over here that actually I have prepared, a simple a diagram to show us with relation to this whole game, where is the angle of incidence, the angle of reflection, and the point of incidence. Okay, so can you all tell me what is the most important thing, okay, or what do you think is the relationship between these two angles in order for the ball to go in? Chandra, want to give you a try?
I think
Okay, class, can you please pay attention to Chandra? Yeah.
these two angles looks like it's quite similar.
It's quite similar, okay. So just now in the video, you actually saw how the pool player measured the angles using the chalk, okay? So he was trying to make sure that the angle of incidence is equal to the angle of reflection. Very good, alright? Then after that, he's able to make the shot. Okay, so of course, in the exam, you won't be drawing something that looks like this, okay? You won't be drawing something that looks like this, alright? Instead, what you will be doing is to draw a diagram that looks like this, okay? So I want to make use of this opportunity here to basically remind you of some of the way you should draw this diagram in order not to confuse you with the chapter on vectors in what you learn in mathematics. Okay, first and foremost, can you all see that the angle here, or rather the arrowhead here, is drawn in the middle of this line, okay, of this incident ray. You see over here, right? The arrowhead is drawn here. So please, when you draw your ray, okay, put the arrowhead in the middle. Okay, don't put it at the end. I know in math you learn to sometimes put it at the end. Okay, that's the first thing that you want to take note of. Now the second thing that you want to take note of is how to draw the normal. Okay, so if you can see over here, right, the dotted line is called your, Timothy?
Dotted line is called normal.
Normal, very good. Okay, when you want to draw the normal, you want to draw it perpendicular to the
Surface.
Surface. Okay, so in this case, what's the surface?
Mirror.
A mirror. Okay, so maybe in the exam they'll give you a mirror that's tilted. Okay, let's say this is the mirror. Okay, let's say this is the mirror. Alright, so it doesn't mean that your normal is still going vertically downwards like what you see in the diagram over here. Alright, remember that your normal must always be what?
Perpendicular.
Perpendicular, very good. Okay, so this should be a right angle. Okay, and then this will be called your normal. Okay, so from here you will draw your incident ray, and your incident ray, as what I reminded you earlier, the arrow should be in the middle. Okay, then after which your reflected ray will be as such, and Chandra, just now you were saying that the angle of incidence must be
equals to angle of reflection.
equals to the angle of reflection as such. Okay, very good. Okay, so class, after today's lesson, please go back, make sure you try to remember this diagram and how to draw it well. Okay.